Hello all, and thank you for listening to this video of Mr. Laxton talking through what is the number E. Alright, so that's my essential question. What is the number of E, and how do I perform math operations with it? Alright, so I'm not going to take the whole lot of time to actually kind of go through and kind of prove about why we have this number E. This QR code up here in the top left, or top right, excuse me, talks about the number E. It's a video that talks about it really good as well. I'm just going to kind of go through more of like how do we actually graph with this number E, and how do we go through some operations with it and things. But really, the number E. Okay, you might think it's a letter. Yes, it is a letter, but also in math, it's a number, and it's a number that's a lot like pi. All right, pi is an irrational number. E is an irrational number. E is a number that goes on and on and on forever, and it's this guy right here. E is 2.718281828459, and going on and forever. All right, I'm sure there's people out there that can name this to the thousandth decimal. All right, but today we're just really focused on, hey, E is a number. All right, and how do we graph with it? How do we do some different things with it? The main thing is, and the main reason why we found this is that it approaches this expression 1 plus 1 over n to the n power is what E approaches. So this guy gets really, really close to that number, 2.71828, but it doesn't really go past that. All right, and that kind of goes along with that exponential growth and decay, kind of those with that n of how many times it compounds per year or per whatever. But that's really all I'm going to talk about E. We can talk about E a little bit more in class about what this guy is and how it works. But I'm going to just jump into, hey, how do we actually work with this guy? All right. So here we go. Simplifying expressions containing E. So I'm just going to write a little note here for myself. Treat E just like X's. All right, so for these, we're going to treat E, and we're going to go through here, and if I can find that back again, we're going to treat E just like it's an X, okay? So here we go, as I look at this, e to the negative 3 times e to the 7. You remember that you add that negative 3 and the 7 together, so this is going to be e to the 4th over e to the 9th. All right, and remember, if I have 4 e's on the top and 9 e's on the bottom, all those e's on the top are going to cancel out. I'm going to be left with 1, and then I'm going to be left with e to the 5th on the bottom. Okay, so nothing crazy there. Just treat those guys just like they're x's, kind of like these are just exponent rules. All right, awesome. Here we go. The second example, you have to kind of look at this as two separate ways. We have 24 over 8, and then we have, where's my green? Wake up, wake up. All right, there's my green. 24 over 8, obviously 24 over 8 is 3, and then e to the 8 over e to the 5th, remember how you subtract those guys together again, so this leaves us e to the 3rd power left on the top, and there's nothing left on the bottom. All right, example number 3, remember that this 2 has to talk to all of these things, so it's going to be 2 to the 2nd power, and it's going to be e to the negative 5x times 2, so this is going to be 4 e to the negative 10x, all right? And remember, what do we do with negative exponents? We throw them to the bottom. So now the 4, remember, has a happy exponent. The 4 is raised to the 1st power, so the 4 stays on the top, and the e to the 10x goes to the bottom and becomes positive, all right? 4 over e to the 10x. Awesome. All right, so here we go. Evaluate these expressions containing E. Just use your calculator. So this is going to be the nice thing about when we start graphing this E, is that you can really just put them into your calculator and get decimals, and that's okay. All right, and your calculator has this E to the X button. You probably have to do second E to the X. And then you put in the number 3 here, so second e to the x3, and that should come out, you should get an answer of 20.086. All right, so make sure you know how to do that. Make sure you know where that e to the x button is, so you get e to some power, and it's here, it's the 3rd. All right, awesome. Here we go. So this is the same guy. You can go second in your calculator, you can go e to the x, and you can just put in negative 1.2, and you should end up getting this 0.301. right, is what you should get out of there. All right, and this guy over here, you just do 1 divided by second e to the x to the fourth. And if you plug that in your calculator, you should get 0.018. All right, so make sure you know how to put those guys in your calculator. That's going to be important for when we graph them here in a little bit. All right, so here we go. We go with graphing these e's. All right, it's going to be really similar to graphing exponential growth or decay, and that's it really is going to be exponential growth and decay, and we're going to talk about that here in a second. So make sure you do yourself a favor, highlight this guy, a times e to the r times x minus h plus k. You guys got it here. It's kind of the same deal that h moves it left and right. And remember, that's the opposite of what it looks like again. Okay, h moves it horizontally, and your k moves it vertically up and down. And that is what it looks like there. Your a again here is your y-intercept. All right, a lot of times that's 1, but not all the time. And now we have this little new thing. It's that r. We didn't have an r in the exponential growth or decay, but this r is huge. If your r is bigger than 0, so if your r is positive, your graph represents exponential growth. All right, and if it's negative, so if it's a number less than 0, you will have a graph, and you guessed it, that's graph's exponential decay. All right, so you got to know here if this is exponential growth or decay, and that's how you go through and plug them in. All right, so here we go. Graph this function y equals e to the 2 times x plus 1 minus 2. Okay, so I always like to just go through, find my parent function. All right, just like we did before, you got to find that parent function, and then we're going to move it my up, down, left, and right. So again here, my a is 1, so that's my y-intercept. All right, remember, if there's nothing out in front of it, it's 1. And your r is this 2. All right, so r is 2, and obviously that 2 is greater than 0, so this is going to be exponential growth, is what it's going to look like. Okay, so that's just kind of a way to check yourself to make sure that you got it in here correctly. Okay, awesome. So again, let's just go through, plug in -2, -1, 0, 1, and 2 into my calculator. I'm just going to kind of go through and plug in right around 0 and 1 because this 2 and -2 get pretty small. But here we go. If I plug in f of 0, that is going to be e times 2 times 0. And 2 times 0 is going to be 0. So e to the 0 power is 1. All right, that's good. That's my y-intercept, what we should have. All right, so now if I find f of 1, that's going to be e to the 2 times 1, which is e to the 2 power. And the nice thing about this is you just plug them into your calculator. So here, I'll just write that in here. Plug into calc. All right, because you're going to get a bunch of decimals here, and that's okay. And you get a decimal that's right around 7.4. In that area. And I know that 2 is going to be kind of a really, really big number, so I'm just going to kind of scratch that for now. So I'm going to go back and do f of -1. So again, you might get scared by the negatives, but don't, because this is just plugging it into your calculator. So that's plugging in -1, so this is going to be e to the -2 power. So now in your calculators, you need to do second e to the x to the -2 power, and you should end up with 0.135. All right, and this number gets really, really small too, so that's all I'm going to really worry about here. Okay, so these points that I have here, I have -1 and then 0.3135 is right there. I go 0, 1, and then I have this 0.17. So 1, 2, 3, 4, 5, 6, 7, and it's 0.4, so I'm going to go not quite all the way halfway, but you guys get the gist. All right, so here's my parent function. It gets really, really close to 0 because exponential growth on the left side, and then it grows exponentially on the right side. But now I have to find out, hey, what is my h and what is my k? So I know that my h equals -1 and my k is equal to -2. So this moves left 1 and down 2. All right, so that's my -1 and my -2. All right, so now I just take every point, I move it left 1 and down 2. So do your best here. So I got to move left 1, down 2. So there's 1, there's 2. Left 1 down 2, that's going to be a nice point because that's on it. And left 1 down 2 is going to be somewhere in there. So now my graph comes in like this, and you got to make sure, and this is where you got to be really precise, it gets really close. Oh, I don't want that. It gets really close to that -2 line now, so it gets really, really close to this line, but does not go past because everything moves down 2. So I take this point, move it left 1 down 2. Should be really, really close to that -2, but not past. All right, so here we go, my domain and my range. My domain is x equals that all real numbers. There's no restrictions in my x's. And my range is my y's are greater than -2. That line, because this line right here is y equals -2. So everything has to be bigger than that -2 for my y's. All right, awesome. So go through and graph that. It's just as simple as this. Plug it into your calculator and then move it with your h and your k. All right, so hopefully there's not a whole lot too terribly different there. All right, and these this last guy here is this compounded continuously. This a equals pe to the rt. A equals pert, as I like to call it. And these guys are really the same deal here as what we've kind of been going through. This p is my initial amount, and my r is my rate, and my t is my time. All right, so we just got to go through here and actually plug these guys in and see what we got for compounding continuously. So this isn't compounded every year or daily or monthly. It's compounded continuously. All right, so here it goes. It says you deposit an initial amount of $1,500, which is my A, or my P in this case, excuse me. That earns this percent interest, so I'm going to move that twice, so 0.075 interest, that's my R, and how much is left after 1 year and 5 years. All right, awesome. So now here I just plug these guys in. A equals pert, so I go $1,500, and then E to the R, which is 0.075, and then times my T, which is 1. All right, this equation is A equals 1,500, e to the 0.075 times 5. All right, and awesome. So now as I just plug these guys in my calculator, I would do this. Make sure you do this into your calculator first. Always make sure you do your exponents. And you should end up with 1616.83 dollars for the first one. And if you plug this into your calculator, make sure you do this in your calculator so you know you got this. If you plug this exponent in here first, you should get 2182.49. All right. Awesome. So again, I know there's a lot there with that letter E and the number E, excuse me, for this math, but shouldn't be a whole lot different. It's a lot just plugging that guy into your calculator, moving it with your H and your K again. So awesome. I promise we'll do a lot of examples like these. They're pretty similar to the exponential growth and decay. They're just a little bit different. So again, thank you for listening, and have a good rest of your day.